We want to expand 1 minus I to the 10th power. If I was to graph this, what quadrant would that be in? 4. Very good. Because over 1, down 1. Quadrant 4. Let's find the modulus. 1 squared plus negative 1 squared, that would give me square root of 2. So I'm going to put that on the outside here. Tangent of theta equals negative 1 divided by 1, which is negative 1. What family am I dealing with there? Pi over what? 4. What pi over 4 is in quadrant 4? What is it? 7 pi over 4. So you guys, this is not hard. You just got to know the steps of doing these problems here. Now, I got to raise square root of 2 to what power? 10. And then multiply these by 10. Alright, so when I say 7 pi over 4 times 10, that gives me 70 pi over 4, which reduces to 35 pi over 2. Alright, now let's talk about how we're going to rewrite this. It's raised to 10th power. Doesn't mean you're just going to cancel that square root out. It's gone. How do we, this is why we did our math workshop third notes. How can I rewrite square root of 2? It's 2 to the what? 2 to the 1/2, can I? When you raise something 1/2, that's the square root. So I'm going to rewrite it like that, raised to 10. Okay? What's 1/2 times 10? Because that's a power to power. Do y'all see that? So that's be 2 to the 5th, which is really what? 32 will go outside. Does everybody see how I got that? And the reason why we can do that. We good, Mason? Now, I'm going to put cosine of 35 pi over 2 plus I sine 35 pi over 2. Now, let's do this. 2 goes into 35 how many times? 17 times with 17 and a half. So if I got a unit circle right here, 17 1/2. I went around it, I'll get 16 right here, wouldn't I? I need one more, that's 17, isn't it? Half is down here. Do you see this? Okay, so cosine of that would be 0. Sine will be what? Don't worry about the 0, but 32 times negative 1i is what? And that would be my value. You have 2 of these on your test on Friday. Do we feel better now than yesterday? What's wrong, Jesse? What are you having trouble with, hon? On the polar form?
For like 29 through 41.
That's right in polar form. Are you getting the angle wrong or the modulus wrong?
Different on every one.
Oh. Alright. Let's turn to our notes. Take a deep breath. It's not hard. I need you to take a deep breath right here. We're going to do 2 examples today. If you just learn the steps, it's not hard. If you don't go home and make yourself learn the steps, it's going to be rough.
You said we were going to take the hardest one here tomorrow.
Yeah. Well, look at the formula right there. I mean,
Are you going to go?
no. It's not. I mean, you don't have to really memorize that formula. Like I'm going to teach you how to do it without. Yeah.
Oh, that.
So now, I'm just telling you what all this means in its own little way, because that's going to confuse you. So we've been expanding them. Now we're going to find the roots. So like it says the cube roots. What's cube mean? 3. So that means you have 3 answers for that. If it says find the 6 roots, you're going to have how many answers? If it says 8 roots, you're going to have how many answers? 8. So we want to find the cube roots of 4 square root of 3 plus 4i. That's a complex number. We want to find the cube roots of that. How do you do the cube root? Well, here's the formula. First thing, just like the de Maurier's theorem, you got to put it in what form? Polar form. The first step. Polar form. Now, do you remember how de Maurier's theorem? Once you put it in polar form, you took the modulus and raised it to the power. Well, here you take the modulus and raise it to the root. So it's still the same state. You take the modulus, like if it's cube root, you can take the modulus and raise that modulus to 1/3. So the same process, you just got to remember, I'm taking roots, I'm going to have a fraction. Does that make sense? Okay, after that, then you go inside, just like you did de Maurier's theorem, you multiply, didn't you? Well, guess what you're doing here? Divide. You see what I'm saying? So it's very similar with the steps. Alright. So, first thing we'll do is put this in polar form. (48 plus 16, 64, square root of 64, 8. To find the tangent, 4 divided by 4 root 3. What happens to these 4s? If I was to graph that in the complex plane to begin with, what quadrant would that be in? Quadrant 1. What family gives you a root 3 over 3? Pi over 6. Which pi over 6 is in quadrant 1? Pi over 6. So let's write this. So I'm glad that each of these problems practice polar form. So I feel like you keep getting repetition with that, you're going to get better at putting something in polar form. Alright, so here we're finding the roots. Finding the roots. De Maurier, I would have done 8 to the 3rd, but here I'm finding cube roots, I'm going to raise 8 to the what? 1/3. Let's put 8 to the 1/3. Now this is where it's a little bit different from de Maurier's theorem. And this is what the formula is telling you, but I'm like I said, don't memorize formulas. You just memorize, if you just remember steps, don't try to remember all this. This is where it's different. You got to take, my box again like this, your pi over 6 and add 2 pi n. I'm going to explain this in just a minute. So we took the 8, we raised it to that cube root 1/3. This is what the formula is telling you to do. That formula says 2kn. Guys, that's another variable we got to remember. Haven't we added 2 pi n to the Rose problems? Let's just stick with n. Are you good with that? Because that's one more variable. It doesn't matter. It just represents something. So that's why I'm saying not memorize this. Just remember to take your angle, add 2 pi n. That's what that formula is telling you to do. And you're going to divide it by the root. Cube means 3, so you put 3 and 3 there, okay? Does everybody understand that? So, yes.
So is the, well, just go ahead. We're going to answer here.
No, go ahead. What's your question?
I was going to say, is the n going to be 3 in the equation? So the 2 pi n?
No. We're about to do that. So, yes. So, how many answers did I tell you that you got to have in this problem? So, what 3 numbers are you going to plug in? 0, 1, and 2. Do y'all see that? Okay. Now, all right. What's the cube root of 8? 2. All right. order of operation, you got to do everything in the numerator and then divide by the denominator, okay? So just remember that too. That's where some students have trouble with. If I plug 0 in here, and remember, once you do this one time, you'll get the same thing on the other side. So you just got to do this. What's 2 pi times 0? 0. 0 plus pi over 6 would be? Okay. Now take pi over 6 and I divide it by 3. Is that going to affect the numerator or denominator? Because you flip that 3, it'd be 1/3, wouldn't it? So it'd be pi over what? 18. Pi over 18. So 2 cosine pi over 18 plus I sine pi over 18. Have I taught you anything about some pi over 18? So that's your first answer. That's as far as you can go with that. Let's go for the second answer. I'm going to plug 1 in. 2 pi times 1 is 2. 2 pi plus pi over 6. I want you to do that in your calculator and tell me what you get. Don't shout it out right now. I just want to make sure we know how to type that in the calculator. Get 13 pi over 6. That's what you should get. I want to make sure we all got that.
Mr. Hester,
Yes, ma'am.
when the bell rings, I need Luke Lamar, Nick Lowry, and Jaden Sims in the recruiter room upstairs in the rotunda, please.
Yes, ma'am.
Thank you.
Okay, so did everybody get 13 pi over 6? Now, divide that by 3, and you should get 13 pi over 18. Is everybody good with that? Okay, you don't know how I'm getting that?
Yeah, what am I supposed to do?
Okay, so did you get the pi over 6 plus, did you put 1 6 plus 2 in the calculator to begin with? Okay, watch this, here we go. I plug 1 in. 2 pi times 1 is 2 pi. 2 pi plus pi over 6. Did we put pi's when we put this in the calculator? No, you put 2 plus the 1 6. Okay. So you get 13 pi over 6. Divide that by 3, you should get 13 pi over 18. Do we know anything about 13 pi over 18? That's your answer. Like right here. This is how you write it. 2 cosine 13 pi over 18 plus I sine 13 pi over 18. We got 2 answers. How many more do we need? 1 more, so I'm going to plug what in for n now? 2. 2 pi times 2 is 4 pi. 4 pi plus pi over 6 will give you what? 25 pi over 6. Very good. 25 pi over 6. Divide that by 3, you get 25 pi over 18.
That's a 17 pi over 15.
13 pi, buddy. So those are your 3 roots for that complex number. Those are your answers. So you got pi over 18, 13 pi over 18, and 25 pi over 18. I want you to notice something. Does any of those values go over, if I divided any of those out, would that go over 2 pi? No, 18 goes in 25 one time, don't it, with some left over. None of these values would ever go over 2 pi. Like if you were to divide them, it's not going to happen, okay? You said, Mr. Chester, what if I only miss, I got 2 of these right and you miss 1? You will get partial credit on the test, okay? All right, let's turn over. Got one more to do. We're going to do.
So most of these answers are where you can't work out.
Well, no, the next one you can work out. It just depends. How many roots we're about to find on number 2? That means you got to plug in.
0 or 5.
Number 3.
Because on your quiz you'll find 4 or 5 roots. So this one's pretty easy though. This one it works out very nice and easy. Number 2, the 6 roots. All right, what's your modulus would be? Well, put it in polar form. Or z would be what? Well, if you square negative 64 and take it to be 64. All right, polar form. 64. Okay, this is a very simple one, negative 64. If I was to graph that, wouldn't that be on the axis? The real axis, the same spot where it would sit, 0 or pi? Pi. So I'm going to put cosine pi plus I sine of pi. So there's your polar form right there. Okay, if I was to graph this on the complex plane, wouldn't it be graphed over here? Somewhere, negative 64? Yeah, that's where it would be. So same spot as pi. Now, I got to raise 64 to what power? 1/6. Cosine of pi plus 2 pi n over what? 6 plus I sine pi plus 2 pi n over 6. So you put your angle, add the 2 pi n, and divide it by the root. 64 to the 1/6 is 2. Now we're ready to plug in our numbers. And we're going to have 6 answers for this one. It's crucial you start studying tonight. Just telling you. Alright, so I'm going to plug in what first? 0. 2 pi times 0 is 0. 0 plus pi is pi. Pi over 6. So we're going to have cosine of pi over 6. Alright. Can you tell me cosine and sine of pi over 6? That means you need to keep working this out then. What'd you say, Mason? Did you say anything over there? Alright. Cosine of pi over 6 is what? Root 3 over 2. Sine is what? 1/2. I should put 1/2 I, but I put I 1/2 for some reason. Alright. You can do this one of two ways. You can distribute the 2, or you could write, you can't combine root 3 over 2 plus 1/2 I because one's a radical, one's not. Or, okay, I just distribute. Watch this. If I multiply this by 2 right here, wouldn't those 2's cancel out? So I'm left with root 3. If 2 times 1/2 is what? So that is your first answer. So I plug 0 in. What now? Yeah, you got to remember that I right there. Yeah, 2 times 1/2 is 1 I. You can put the 1 or just put I. It's fine. But the I's got to be there. All right, now I'm gonna plug. What's my next value? I plug 0 and I'll plug what? 2 pi times 1 is 2 pi plus pi is 3 pi over 6 reduces to. So this is an easy one right here. So 2 cosine of pi over 2 plus I sine of pi over 2. What's cosine of pi over 2 give you? 0. Do I need to worry about that one? What's sine of pi over 2? 1. So that'd be 1I, wouldn't it? 1I times 2 is what? There's your second answer. So we plug 0 and 1 in. Now we're going to plug in what? 2. 2 pi times 2 is 4 pi. 4 pi plus pi is 5 pi over 6. You need to show pre-cal this. Okay. Cosine of 5 pi over 6 is negative root 3 over 2 plus sine of pi 5 pi over 6 is 1/2 I. If I was to distribute the 2, what would happen to that 2 and that 2 in the denominator? Cancel, so you got square root of 3 plus I. There's your third answer. We're halfway there. Because cosine of 5 pi over 6 5 pi over 6 and quad 2, so that's going to make it a negative. Halfway there. Does everybody understand why that's a negative right there? Okay. Yes.
How many of these are going to be on the test?
1. But you're going to find, I think, 5 roots.
Is it going to come out like this, or is it going to come out like that?
I forgot. I think I put an easier one. Probably like this.
Is this the easier one? Or
This is an easier one than the one we just did. All right, next. We plug 0, 1, 2. Let's plug 3. What's 2 pi times 3? Wait, 0, 1, 2, yeah. 6 pi plus pi is what? 7 pi over 6. Two pi, we plug 0 here, plug 1 here, plug 2, now plug 3. 2 pi times 3 is 6 pi plus pi is 7 pi. Now we know why we have Tricky Tuesday every Tuesday. Cosine of 7 pi over 2 is negative root 3 over 2. Alright, that would give me a negative root 3 minus I. There's your fourth answer. We plug 0, 1, 2, 3. Now we plug 4 in. 2 pi times 4 is 8 pi. 8 pi plus pi is 9 pi over 6, which reduces to, this will be an easy one, 3 pi over 2. Cosine of 3 pi over 2 is 0. Sine of that is negative 1. So you would just have negative 2i. There's your fifth answer. Now our final answer. If I plug 5 in there, I get 5 times 2 pi, which is 10 pi, plus pi is what? 11 pi over 6. Cosine of that is root 3 over 2. Sine of that is negative 1/2. So that will give me root 3 minus I. So there are my 6 answers, my 6 roots of the original complex number, negative 64. You thought this better than the more answer?
Because it's just, you just set it up once and then you just plug numbers in.
That's the last new thing that's on your test on Friday. Yes. Study session day, we'll review everything and go over some more of this.
Can you record the study session?
3:30. 3:30.
Because I would love to come. Thank you.
Thank you, bud. We'll do that checkpoint tomorrow, okay? Luke in class.